Hi, I am Manon Vialle, and today I represent to you our work on supporting perception of spatiality in dance in augmented reality on behalf of my co-authors, Fdili Alaoui, Mélina Skouras, and Elisabeth Schwartz. This work focuses on representing the spatial aspect of dancing using augmented reality. There is a body of work in the literature that represents the dancer's body in augmented and virtual reality. Still, these works focus more on the movement of the dancer and not so much on the perception of space in the choreography. Moreover, during our previous study on visualizing dance quality in a Hololens headset, we noticed that dancers seem to lose a sense of space when trying to follow a dancing avatar. In this project, we build on our previous work and extend our prototype to support the perception of spatiality for dancers. Just like in our previous work, we focused on a specific style of dance of Isadora Duncan. She's a choreographer from the late 19th century, early 20th. In her work, she wants to embody what she described as the natural movement. She defines the natural movement as unconstrained, as opposed to ballet, which was one of the main styles of dance at the time. In Duncan's dance, all movements come from the solar plexus and propagates through the body in a wave-like motion. To be as faithful as possible to this style of dance, we followed a co-design approach with a connoisseur dancer and fourth author of this paper, Elisabeth Schwartz. Elisabeth is a third-generation dancer of Isadora Duncan style. Through our co-design approach, we met regularly with Elisabeth to discuss the prototypes or to take dance classes with her to immerse ourselves into the style of Isadora Duncan. We started our co-design process by taking inspiration from the Souten dance notation. In this notation, the body is represented as a stick figure. This is similar to the ribbon model that we developed in our previous work. This model was tailored to the style of Isadora Duncan and assessed in our previous study with dancers, where we showed how it represented faithfully the natural movement of Isadora Duncan. To render the dance's spatiality, we wanted to design a system that visualizes the trace of the body's position in space. Since we're working on a ribbon model centered around the solar plexus, our first idea was to display the trace that the solar plexus leaves in space. Moreover, the trace displayed in time would help the dancers understand the temporality of movement and its spatiality. We also took inspiration from the Souten dance notation to use key poses, also known as keyframes in computer graphics, which would be placed along the line of the solar plexus. These keyframes would visualize key moments of the choreography placed in the 3D space. This led to our first prototype. Along with Elisabeth, we decided to iterate on our prototype by adding moments of impulse, which are small animation instead of key poses. Indeed, the keyframes do not fit the style of Isadora Duncan because they are too static. Instead, the small animation represents the impulse in movement that makes the wave continue expanding and retreating. The question was then, how many moments of impulses are useful to help the dancers better perceive spatiality? One future moment or all the future moments of impulse? To better answer this question, we decided to run a structured observation to try 3 different options. First, seeing all the future moments of impulse, which we call prototype all keyframes. Second, just seeing the next moment of impulse, which we call prototype next keyframe. Lastly, seeing the next 3 moments of impulse, which we call prototype 3 keyframe. We also wanted to see if removing the red ribbon could help dancers engage physically with the prototype by following the future moments of impulse that represents a feed forward for the dancers. The structured observation took place as a half-day workshop. We had 5 dancers who were familiar with Isadora Duncan's philosophy of dancing. They first learned the prelude dance with Elisabeth. Then we separated them into 2 groups. The first group experienced first with prototype all keyframes, then with prototype next keyframe, and the second group vice versa. Lastly, They all experienced prototype 3 keyframes. Each dancer had 10 minutes to experience with each prototype. After each experience, we had dancers record their experience on body maps and through group discussions. We analyzed the data using thematic analysis. Participants noted that each prototype let them see different aspects of spatiality. For example, one participant thought that prototype next keyframe let them see better the direction as shown on their body map. Another participant noticed that they were more conscious of the space when using prototype all keyframe. Participants had different embodied experience with each prototype, going from just observing to marking the dance, to dancing, and finally to improvising with the prototypes. In this video, we see a participant improvising with all the different moments of impulse. All participants mentioned that they tried to superpose their plexus movement to the blue line in prototype 3 keyframe, as if their body produced it. They reported that doing so helped them engage in the dance and move with the blue line. Participants experienced a big learning effect when using the headset for the first time, whether it was through trying to find the best point of view to observe the scene, or to getting used to dancing with the headset on. However, once they got used to using the headset, they saw a big potential of such technology, especially for learning and increasing autonomy in the learning process. However, they all agreed that it cannot fully replace a human teacher. The participants' experiences with the third project suggest that creating a virtual alter ego displaying a body dancing is not necessarily desirable, as it might hinder the dancers in body engagement. In contrast, erasing the bodily representation in the augmented world seemed to hold great potential for the dancers to use their body more creatively. Our results show the potential of feed-forward to guide dancers in performing movements. We saw the value of designing systems that complement each other rather than one system that fits all needs and desires. Overall, our findings do not suggest that augmented reality technology can replace a human dance teacher. Instead, they highlight how augmented reality can support students in learning different aspects of dance without depending on official classes to have access to training. We believe that such collaboration, putting at the center the expertise of a connoisseur, is fundamental in the design of technologies to support dance and kinesthetic creativity. Moreover, we value design approaches that dig into particular vocabularies in dance in a deep and committed way through collaborating with connoisseurs, avoiding generic and all-encompassing dance languages. Thank you for your attention, and I'll answer any questions you may have.